Good morning and welcome to the Northwest Astronomy Festival. We've got to go up to the Astro van.
Neptune, Uranus, Saturn, Jupiter.
And it's Saturn, not Satan, you fucking spoon. The van's owned by a friend of mine called Andrew. You'll meet him sometime later today, I'm sure. Talking of Andrew. Shut up. Shut up.
I thought so, the odds are very good. So if you would like one or two.
Random. Is that one? It's just a bit huge, isn't it? What? Yep.
It's
It's not a mortar cannon. It's not, it's a Dobson. Oh, look at that! That's cool.
Some of their cosmic velocity, so some of the ones that are multiple tons may retain 20, 30, 40, 70% of their cosmic velocity, and they're the ones that make craters. They're the ones that do things like that. If an individual lump like that fell, all you'd end up with is like that. They don't make a crater. It's called an impact pit because it's a small, localised area. You know, even when the meteorite fall, where they fragment like that, you end up with what's called like a stream field ellipse. So obviously, as you've got Earth here, as it hits the atmosphere and it fragments, you get a shower of stones fall. Now the ones with greater weight fall the furthest, and the ones that are smaller fall. So you end up with this sort of elliptical stream field of where they will fall. Now some of the smaller ones that land, you know, like this, if they land on a tarmac road, still one wonder.
Don't touch anything.
Let's say when they do fall on a car, the things that they hit have a value as well. There was one in 1991.
This is Martin, by the way, a friend of mine.
This red Chevy Malibu that was on the driveway. They were inside watching telly and they heard a bit of a bang, went outside, and there's a big divot in the back of the Chevy Malibu. It was only like a $500 car. They sold it for 10 grand, or more than that, I think, because it actually had a value. So now talks about it, really, this car, you know, was hit by a meteorite, blah blah blah, and bits of the meteorite have got red paint on where it here. You know, I mean, but it creates like a story, and that's what part of all this is about. It's not just the science of it. There's all the you know, the earth impact, if you like, you know, of the story, how they found the finds, what they hear, you know, how, you know, etc., etc. So, you know, there's quite a lot. I mean, meteoritics is one of the fields of science where amateurs can make a huge, huge difference. And collectors like us, you know, although we're private collectors and we come out and do shows like this, you know, like I say, just to hold something in your hand that, you know, is from an asteroid in space is pretty cool. This is, that's a piece of Mars. It's a slice of a Martian meteorite. The thing with like planetary blasted off by a meteorite. Yeah, I mean, all you got to do is look up at the moon, and all those craters on the moon have been caused by meteorite impacts. So obviously, if you've got a big, you know, you've got the moon, meteorite hits it, bits of the meteorite will mix with the surface of the moon, and bits of it will fly off, and that is exactly what happens. Bits of it fly off. An impact on Mars, some of it has flown off, and then that has, you know, impacted on Earth. But yeah, that's a genuine reason. That's the thing with lunar and meteorite, they actually contain some of the gas. They contain some of the Martian atmosphere. So from the Viking landers, where we've got samples of that, they literally probe that, and you have like a percentage ratio of all the gases there. Perfect. So basically, most of the asteroids come from certain like same family groups. So they've got like CK asteroids and CR asteroids and Type 2 and all these different types. and they match them up, so they can look at the stone meteorite and say, well, this sort of matches. And when you look at the graphs, you know, you've got sort of like a graph like this where it matches the
book.
You very probably did, yeah.
Yeah, because I told you had to tell me, and you told me no.
Yeah, guess the way. Yeah, well, I'm not going to tell you. You can have a go, but you know.
They're just that's
You
just
know what
wrong.
was weird? I actually had the specimen card out for it. I remember.
This is one impressive collection. You know that, don't you?
Yeah, I'd like to think so. Yeah. You can have to have a photo of you photographing my collection and stuff.
I'm videoing your collection, not photographing it.
Yeah. You remember the Chelyabinsk one?
Oh, I do.
Yeah, Russia last year. These are all pieces of that. This is one of the very first pieces to come out of Russia. A friend of mine, a German meteorite collector, had a friend who's a professor.
So this is the Russian meteorite.
That's the Russian, yeah.
We need to tell YouTube what we're doing, because they're just going to think we're just showing random rocks.
15th of February, 2013.
I remember it.
Yeah, it was yeah, pretty amazing. So this is
How much?
Now that chunk weighed 650 kilograms. Now bear in mind, fell in February, made that hole in February, and then pulled it out in January. So you've got an ice cold Russian lake, and that's been sat at the bottom of it for sort of 6 months or more. They pull that bit out, 650 kilograms, and that's only a part of it.
Really?
That's only one part that made that. Obviously many other pieces. If you have a look at this photo here, you can see all the trails in the snow, all these lines, and that's from hunters going out in the snow.
There you go. I'm just getting the light reflection off it. There you go.
Yeah, so that's all the parts made by hunters. So if you imagine holes, so as they obviously you've got 2 foot of snow, where that rather than seeing a black meteorite on top, what you actually see is a hole, and you dig out the hole, and at the bottom of it you've got a little meteorite like this. Obviously you get many collectors came out. Some of them are tiny, that's a little vial of individuals. So some of them are very small, and then you have larger ones like that.
The difference in size.
And that's still, you know, that's quite a relatively small piece. But yeah, that's the Russian Chelyabinsk meteorite.
Look at that.
So that's a slice. So Chelyabinsk is a stone meteorite.
Yep, like the one I've got around my neck.
Like the one you've got around your neck, okie doke. And you can see these veins here.
Yep.
These are impact melt veins. So that's from an impact, not of the impact with Earth. That's from the asteroid that has come from, has collided with another asteroid in space. And that impact has caused part of the meteorite to melt. And then it forces the molten meteorite into these veins throughout. So the pressure and heat cause it to melt and then force it into these impact veins. That then solidifies and it becomes a new body, and that is then what the pressure causes it to fragment. And obviously if it's going to fragment it on the weak point. So those melt veins, that's where it splits, that's where it falls, and that's what you end up with here. So some pieces show the melt veins, others don't. This dark black portion here is pure melt, and this is a sample that's purely made of this impact melt material there.
Yeah. Now I know we've had this conversation, but how did we start again? How did we end up starting, and what was your first meteorite?
How did I start? I've not got my first meteorite, but the
that's just not right.
piece of the first meteorite was this. It's Campo del Cielo, which fell in 1576 in South America. It's one of the most common iron meteorites. Basically, meteorites are split into 3 basic sorts: stone meteorites, stony iron meteorites, and stone meteorites, iron meteorites, and in the middle stony iron. That's a sample of an iron meteorite, very common. Multiple tons of it fell, and like I said, as they hit the atmosphere, they fragment, so it falls in multiple pieces. So although that piece there, this weighs 6 kilograms, you wouldn't want that falling anywhere near you, on your foot, on your head, or anywhere.
I like my head.
That is a relatively small piece. But yeah, my first meteorite was a piece of this, about the size of my thumb, and that's what got me started. And here we are now. The rest is history. All right, guys.
I am.
All right. Had to go our competition there. This is that's the actual prize.
This was the year I was
So
born.
this one. It's a stone meteorite from Northwest Africa, Sahara Desert. It's got a polished section there, so you can see the flexion inside it. But yeah, guess the weight of that one. You don't have to make a donation if you want to; it's appreciated. As long as you put your name, contact phone number, or email address on, I'll pop it in there, and that's what you win.
No, this always fascinates me.
The Widman Staten.
Oh yeah. I was looking at obviously the pictures that I've got and that you've sent me.
Yeah.
And it still fascinates me, the colours and stuff and the markings. Like, look at that.
If you get an iron meteorite, and you slice it, and you polish it, you'll end up with something like this.
It's like a mirror.
It is, that's exactly what. I mean, it's like stainless steel. It's an alloy of iron, along with nickel and other elements, and that's pretty much what it is, so it's an iron alloy. As the iron meteorite has cooled over millions of years, it causes two different alloys to form. They form this crystal structure made of T-lite and camosite, and basically the only way to produce that pattern is through millions of years of cooling. So once you polish it, you end up with that sort of surface. If you then apply acid to it, what happens is it etches away one alloy more than the other, and that's why you can see the structure.
Does it?
It is actually 3D. If you run your nail on it, you can almost feel like a texture, and that's because the acid eats away one material more than the other. But what it shows, that pattern, is you cannot man-make that pattern. The only way to create that is through millions of years of cooling.
Yeah.
So if you have what someone suspects is an iron meteorite, if you file away a surface and you see shiny metal like that, if you then test that metal to say if it contains nickel, that will be number one. Does it attract a magnet? That will be 2 tests. If you then etch that surface and you see this pattern, categorically that's an iron meteorite.
Yeah.
There's nothing else. You can't replicate that. There's no way of fudging it or man-making it. So, yeah, but it's a very pretty pattern. It's used in jewellery. They use it to make watch faces,
Yeah.
etc.
Well, I've just found, we're renewing our vows, me and my husband, and we're looking to get, I want a meteorite wedding ring,
Right.
which we've spoke about, obviously.
Yeah, there are. Gideon is.
What's for the little green dude? Come on.
The little alien. You can't have a meteorite collection without a little green alien. He's.
Only you.
Yeah. That's an achondrite, which is a type of stony meteorite.
Yeah, it looks like this one.
What have you got in there?
This is the one that Nick sent me.
Is that NWA? So that's.
I know it's from Northwest Africa, and I know it's 4 billion years old. Yeah. That's as much as I can tell you.
A stone meteorite.
Just so you can see.
You got that. So that's an example of a stone meteorite.
No. Look at the size of mine compared to
That's an
that.
example of an iron meteorite. And then stuck in the middle, you've got a stony iron, which, like you see,
that
very
one.
obviously, if I move that around, you can see that shimmering.
Oh, yeah.
It's got a mix of the nickel iron alloy along with the silicate stony material.
That's cool.
So that's the 3 basic types. And an achondrite basically doesn't have as much free iron in it, so you can feel the weight of it, whereas most will feel heavy for the size. That feels quite light.
Yeah, it just feels like a stone.
Yeah, it does. Yeah, whereas if you look at
that's it.
if you cut a stony meteorite, a common stone meteorite, and polish it, you'll end up, even though not as much as that, because that's got big chunks of nickel
Yeah,
iron.
but you can
if
still
you move
see
this
it.
around, you can still see the flecks. So even though it's a stony meteorite, it still contains these flecks of nickel iron. And that's why meteorites are so important, because these stone meteorites represent material that hasn't been changed. It's not been changed geologically, and it's not from a differentiated planet like on Earth, where all the alloy and the metal and the heavy iron has moved to the centre of Earth. These asteroids haven't had that happen, so it's an even mix of this material. So it's almost like looking back in time and seeing something that we don't have samples of anywhere. So that's why the study of meteorites is so important.